You know what, I'm not going to calculate the molar mass of KClO3. What I'm going to do is, I know how to do molar mass calculations, so I'm just going to look up the molar mass of KClO3. So, find it here. The molecular weight was 122.545. And so the equation is this: 2 KClO3 decomposes into 2 KCl's plus an O2, 3 O2 gases. So what we're going to do is we're going to go from grams of KClO3 to moles of KClO3. And then moles of KClO3 to moles of O2. And then from moles of O2, we're just going to go to the volume of O2 straight using the molar volume. What is the molar volume of gas at 1 atmosphere and 298 Kelvin? Well, that we can either calculate using the equation, or we can memorize it, 24.5 liters per mole. We'll memorize it to 3 sig-figs to keep our life a little easier, maybe. 4.5. And since most of the problems in the book require only 3 sig-figs, well, maybe it'd be better to memorize it more. We'll just go with this. The reason I'm going to go with 3 is because the book asks you to memorize it to 3 sig-figs molar volume. Easier number to memorize that way. All right, so we have 5.74 grams of KClO3. Then a mole of KClO3 weighs 122.55 grams. 122.55 grams of KClO3. And so the grams of KClO3 cancel, that gives us moles of KClO3. And we go back and look at the equation here. It's a 3-to-2 ratio. 3 moles of oxygen for every 2 moles of KClO3. All right, then we know that each mole of oxygen gas occupies 24.5 liters. 24.5 liters of any gas is a mole of gas. So here we could use that number we memorized for, and then what's the answer? This is not the answer because they're doing it at STP. STP has a different molar volume because it's a lot colder. And the pressure is slightly different because it's 1 bar, but they get 22.7 liters. It's a lot colder. Ours is a lot warmer because ours is at room temperature rather than freezing temperature. And so it's just warmer, the gas is going to occupy with a greater volume. So ours is going to be a little different. So let's calculate ours. 5.74 divided by 122.55 times 3 divided by 2 times 24.5. 1.721. 1.721 liters. Oxygen, yeah, at room temperature and pressure. So we get a little bit bigger volume than they do because we're doing it at a higher temperature than that. This is problem number 30 is the old STP. The new STP is bar. The old STP, and the bar is 22.7. The old STP is 0 degrees C in 1 atmosphere. So in this case, the old STP is 22.4 liters per mole. The new STP is 22.7 liters per mole. And the most useful one is 24.5 liters per mole. Here, if we're dealing with atmosphere, or 24.8 liters per mole if we're dealing with bar. Or at 1 bar and 298 Kelvin, it is 24.8 liters per mole volume. And so a bar is a little bit smaller than an atmosphere, so the gas can expand a little bit more by 0.3 liters. These are the two most useful to memorize. so for this particular problem, I would go from grams of calcium carbonate to moles of calcium carbonate, from moles of calcium carbonate to moles of CO2, from moles of CO2 to volume of CO2, using the molar volume. The reaction used to produce chlorine in the laboratory is potassium permanganate with HCl. Produces chlorine. Calculate the mass in grams of potassium permanganate that are needed to produce 9.81 liters of chlorine measured at STP. Your book loves STP. Most of the homework problems are STP based. And so here we would go from volume to moles. There are two choices. We could use the ideal gas equation if we don't want to calculate the molar volume, or we can calculate the molar volume. In this case, they know the molar volume here. And so they go from liters of chlorine to moles of chlorine using this molar volume, which they have memorized. This is the molar volume at a pressure of 1 bar and 0 degrees C, 22.7 liters per mole. Then give us moles of chlorine to moles of KMnO4, moles of KMnO4 grams of KMnO4. What mass in grams of carbon graphite are required to completely react with 42.5 liters of oxygen at 0 degrees C in 1 atmosphere? This is the old STP. So the old STP is like this. Number 32, I'll do it with the old STP. So we have 42.5 liters of O2 gas. The old STP is this. 1 mole of gas is 22.4 liters of any gas. And so that gives us moles of O2. Once we have moles of O2, then we can go to moles of carbon. It's a 1-to-1 mole ratio. So 1 mole of carbon for every 1 mole of CO2, and then it's 12.01 grams of carbon for every mole of carbon. And so this is the old STP, 22.4 liters per mole. This is the one I had to memorize. This is a new STP, 22.7 liters per mole, using bar instead of atmospheres. But again, these two are the most useful for Chem 1A. Okay, I guess we're out of time here. So, pretty much all of chapter 14.